everyone, and welcome back to our learning journey. So, today we are exploring another exciting topic that is ragas. So, to help you understand this better, I'll pass it over to my colleague Dharmesh, who will walk us through the fundamental concepts and needs of ragas to evaluate rag applications. So, over to you, Dharmesh.
Thanks, Samrin, for the intro. So, before we understand what is ragas, let's first do a quick recap on the concept what is called the RAG. So, which is stands for Retrieval Augmented Generation. So, think of this as a standard large language model like ChatGPT as a brilliant student who has read lot of books and doesn't have access to your private files or today's news, and RAG is the solution to do that. So in some simple term, if we see, so it is the generated output is augmented based on the retrieved data. So in the image you can see here that uh, as a user you ask user query, there is retrieval, which is basically accessing your data, which could be your private database, internet, or private files. Uh, Whatever context it will find based on your user query, it will retrieve and prepare the LLM query. And combination of this will be given to the LLM, and LLM will be provide you the response based on the what input is taken here. So in generally, ragas will be having three parts. So the most important part is the retrieval, where it is accessing your private information. Now, can't we just walk away, like preparing the RAG application and just do the job what RAG requires? So to mitigate the challenge. So the biggest challenge in the RAG is the retrieval quality. So which is basically the retrieving irrelevant or the insufficient context leads to a poor answer. So for example, consider your retrieval module as an anomaly of a librarian who you ask the question to the librarian and picks relevant books for you. Now, in case that whatever the books you ask to the librarian, and librarians give you some irrelevant books, or the books which doesn't have the information what you are looking, then of course the end result or what answers you are looking would be not correct, or it will be impacted. So to solve this, we look at the what I call this triangle of truth, where we have to ask three critical questions to ensure that the RAG system what we build is working correctly or not. So first question is the context relevant to the query or not? So did the librarian actually find the right information for my question or not? The second question we have to ask is the response supported by the context? So is the AI actually using the information what we gave it, or it's making something by its own? And the third thing is the response relevant to query or not? So does the final answer actually solve the user problem or not? So by asking this question, we will make sure that our RAG system, what we build, is working correctly. So we evaluate this to prevent hallucination, which is like AI lying. So measure how useful the tool actually is to ensure that it's not flying in blind, and it is in production and giving you some wrong answers. Uh, and just hoping for the best that it will provide you right answer. So solve this, uh, the solution is the ragas. So let's move into the understand what is ragas. So RAGA stands for Retrieval Augmented Generation Assessment. So it is a framework that gives us the ingredient or matrices to test our RAG system at the very detailed level. So instead of just saying that answer looks good or okay, and RAGAS gives us a sufficient way to measure performance of our system. So RAGAS focuses on four core matrices. And it is split into majorly two category. One is generation, another is retrieval. So under the generation, we look at the answer relevancy. Is the answer helpful or on point? Second is faithfulness. So is the answer factually grounded in the data we provided? So these two belongs to the generation part. Comes to the retrieval part. So retrieval, we look at the context precision. So did we rank based information what we have at the top or not in the retrieve chunk? The second is context recall. Did we find all the information needed to answer the question? So these are the four core matrices which RAGAS framework will give as output, and by measuring this, we will actually identify where is the actual problem in our RAG system or application. So let's look them one by one. First, let's look at the first matrix, answer relevancy. So this measures how well the AI answer sticks to the original question without adding extra stuffs or missing to the point. Now Ragas does something very cleverly to measure this. So it you can see in the image, you as a user ask the question and your Ragas application will give you the response. Now Ragas framework will use another LLM to actually derive the question based on the answer what is generated by the LLM, and then uh, it will compare both your user question and what's the other LLM generated question using the tool cosine similarity, and provide you the score between 0 to 1. So for example, here the example you can see, your user question might be where is France, and the LLM response would be France is in Western Europe. Then Ragas internally would generate the question from your the LLM response, that in which part of Europe is the France located. Similarly, this kind of question LLM will generate, and then it will try to compare with your original question and give you the cosine similarity score, which ranks between 0 to 1. So which will be as a score higher means your answer whatever the LLM produced is the relevant to your question. If the answer means his the score is low, then of course it is not what user asked. So this is the first matrix. The second matrix is the faithfulness in the RAGAS. So the faithfulness, which is our primary weapon against the hallucination. So it measures the factual consistency basically. Did the AI stay faithful to documents we gave it? So you can see in the image, this is the LLM generated response. So what the RAGAS framework will do is it will identify the claims out of your response. Also, whichever the document retrieved information you provide to the LLM or to the RAG application itself, there it will identify number of claims from the retrieved context, and then it will try to compare these claims whether those are matching or not, and based on that it will derive the score, which is your faithfulness score. So in the example, you can see it here, like where and when was the Einstein born. So for example, retrieved context would be the Albert Einstein, born on 14 March 1879, was German born theoretical physicist, widely held to be one of the greatest and most influential scientists of all time. So this could be your retrieved context. Now, here ragas, how it will measure is, for example, the it will extract the claim. So claim could be like, let's say Einstein was born in Germany on March 14th March 1879. So this would be referred as higher score because the claim here that 14th March 1879, which is there present in your retrieved context as well. What if the low faithful answer would be that the date on which the Einstein born was different than what is there in your context, and your response says that it's on 20th March. So that could be wrong, or that would give you the lower score because this claim is not correct. And that's how this faithfulness will tell you whatever the information you have retrieved and what is there in your response, whether those are relevant or not. So here also similar way, the higher score means it's better, means your system is working good. Lower score means you need to rework on your system. The next matrix what we have, so those two matrix was for generation. Now comes the retrieval part, how to evaluate the retrieval. So the first matrix in that is the context precision in ragas. So context precision is the matrix that evaluates the retrieval ability to rank the relevant chunks higher than the irrelevant ones, and for the given queries, and then it will provide you the score. What does this mean is that you have for your question ground truth, which this is the answer I expect from the particular model. So those would be your reference or ground truth, and your retrieved context. So to understand this, let's quickly see an example that user would ask a question that can you suggest the book on what causes the earthquake. Now, your ground truth or what books are you are expecting is on the line of plate tectonics as a primary cause. Other is fault lines. Third one is on type of fault movements. So these three could be the primary reason for the earthquake. Now, when we say high context precision, so in high context precision, let's your retrieval chunks have retrieved n number of chunks. Now in this, the first three itself here we can see it's aligned with your ground truth, which means your context precision is high. On the second lower precision, if you see here what LLM or the retrieved chunk was there, suppose it retrieved 5 chunks and first two are relevant, but the third chunk was not so much relevant to your question or what relevant to your reference or ground truth. Then fourth is correct, again fifth was not correct. So with this, we can say that it has some extra information and also in not the higher top arrangement of the required chunk. So that's where on the low context precision, you might have some extra information or the information which is not needed are on top. So when LLM going through this retrieved document, till the time it find the correct information, so many uh, other informations was there, and that's why LLM get confused and give you the wrong response or uh, will give you some extra information which is not needed. So that's where this will measure whether your retrieved context is correct or not. And again, here's the score between 0 to 1. Higher score means it is retrieving properly. If lower score means you need to do some rework on it. The second matrix what we have for retrieval is context recall in ragas. So context recalls measures how many of the relevant documents or pieces of information were successfully retrieved. It focusing on the not missing out the important informations. So here again two things. it rely on the ground truth or reference. Uh, from the ground truth or reference, it will extract the number of claims. Similarly, from your retrieved context, it will extract the number of claims, and then it will compare whether it is means all the relevant claims are matching or not, or something is missing. If it is missing, then it will rate as lower context recall score. If everything is missing, matching, then it will give you the higher score. So in the example, if you see, the question was where is France and what is its capital? And your ground truth is France is in Western Europe and its capital is Paris. Now, if you see higher context recall and the lower context recall, so in higher context recall, first sentence covers the geographical location that is located in the Western Europe, and also in the second sentence, it's mentioned the Paris of its capital. But if you see the lower context, it talks about the first part, which is the geographical location, but it does not give you the information of second half your question, which was what is its capital. So Paris is missing. So it will extract this Paris and Western Europe claims, and it will try to match whether all the things necessary information is present or not. And that's how the score is derived for context recall. Again, here this score is also between 0 to 1. Higher means better, lower means some works needs to be done. So these are four core matrices. Apart from this, additional RAGAS matrices also there, which is addressing more detailed level. So for example, one of the metrics is answer correctness. So this will measure the correctness of the final answer relevant to the ground truth answer. So here it will directly compare between the ground truth or reference you provide and what LLM generated. And based on these two answer, it will say that how much answer is correct. Uh, the second is answer semantic similarities. So here it measures the semantic similarity between the generated answer and the ground truth answer. So here you can understand that uh, it will try to do the cosine similarity and see if our answers is actually matching to ground truth or not. These two were for generation, and these two were for retrieval again. So next is context entity recall. So this is more specialized matrix that checks if the entity mentioned in the ground truth answer were recalled in the context or not. The small difference here between the previously we talked about the claim part. So claim you can understand is it could be the pronoun one word or it could be entire sentence itself. But here entity means it will mainly talk about or look for the pronouns is date, time, those information it will extract, and then it will try to compare whether those things are matching or not in your answer. And that is the difference of context recall and context entity recall. The one more matrix is context utilization. So this will evaluate how much your retrieved context was actually used by the language model while generating the final answer. Now all these metrics will rate between 0 to 1 and give you the final score. Now we talked about these matrices. If you want to implement this RAGAS workflow, then how does this looks? So here you can see in the image, this is how it looks. So there are two things. Ground truth can be given by you, or it can also be generated by the LLM itself for some test data set. For example, you are generating test data sets, then there are two things inside. One is ground truth, and other is your original questions or the user questions. So this will be feed to RAG application. RAG application will get the retrieved context and provide you the answers. And ground truth will be passed to the RAGAS framework. RAGAS framework then will internally uses separate LLM, because that is also recommended that when you evaluate through RAGAS, it would be better to use separate LLM which is higher precision or higher end model compared to what you use in Ragas application, then it will properly evaluate and give you the scores. So Ragas framework will use separate LLM to perform or identify uh, uh, what are the scores, and then finally provide you the evaluation result. And based on this evaluation result, we will have to then think of like which part of in the RAG application is not working properly and where we need to focus on. So two example, the case studies. The first one here is fixing a low context precision. So the problem is initial Ragas pipeline, whatever you build, scores the low on the context precision. For example, it gives you a score of 0.45. So what does this means? This means context precision is lower means uh, the retrieval chunks are noisy, means there are some extra information which is actually not needed, and it is noisy. That's why you got the lower score. So means based on the understanding hypothesis, we can say that let's say chunk size is too large, too much irrelevant information is there in the chunk, which could lead to the uh, some noisy answers or irrelevant answers. So what could be the optimization for this? So reduce the chunk size. If suppose you set the chunk size to 1000 to 250 tokens with 50 token overlap. So this could improve the score. So again, you reevaluate this changes with the ragas and see whether your context precision is increased or not. So conclusion is here if it increased to 0.85, then we can say that okay, chunking was the bottleneck, and that's how we improve the uh, ragas implementation, rags implementation. The second case study, we can say addressing a low faithfulness. So the RAG pipeline scores low on the faithfulness, for example, 0.6. The LLM is hallucinating, so it's not giving you factual results. So what could be the hypothesis for this is the LLM is overconfidence or its prompt is too vague, which is why it is factually incorrect, providing incorrect result. So optimization could be that update the system prompt. For example, you must answer strictly based on the provided context itself. And if the context does not contain the answer or does not contain the information, you must respond, I don't know, instead of giving some random results. So again, you can reevaluate with this prompt change and then again recalculate the faithfulness value. So now if it increased the 0.92, then we can say that using the prompt engineering, we solve this problem and the hallucination issue is not there now. So this is the basically two example, but of course based on the final score what you get on the all the metrics, you will be determining okay what area of the RAG application needs to be worked on and whether your application is proper or not before you go to the production. So I think yeah, those are the things mostly on the ragas.
I had a question. Does Ragas require a human to grade the answers to get a score?
Okay, yeah, that's the good question. So the answer is no. That is the reason why this framework is developed. So it is the framework. So it the Ragas uses a judge LLM, usually a more powerful one, like ChatGPT 4 or higher end version 5 now, or Gemini higher end version to actually calculate the score based on the logic of the matrices. So we seen the matrices. So there would be mathematical calculations behind it, and it is already in the framework implemented. So it will be automatically calculating based on this mathematical formulas and provide you the scores. So actually there is no human interaction required. It's just that there are two ways where you provide the ground truths for some of the metrics. So where if you have ground truths, then you can provide the ground truth while deriving the matrix. Otherwise, it can also generate the higher end model will also generate the truth or reference for you based on the question, and then it will try to give you the result. So this allow you to test the thousands of question much faster and cheaper than the human could do. So I think, yeah, that's the answer for your question.
Okay, so I have one question. So, what if you mentioned about the high-end models using high-end models for their ragas? So, what if in my RAG system itself I am already using some high-end model for the generation purpose? Then, like, what would be the solution to this? What do you think?
Yeah, that is the interesting question. So answer your question, it's not necessary. So in fact, it is often better to use more capable model as a judge to ensure that the evaluation is accurate as possible. But the evaluation happens separately from your actual application workflow. So if you are evaluating this with the same model, also it will provide you the scores which is relatable, but it is not, let's say, when you are doing for the high-end model for generating these scores. But yeah, it is not necessary or must that you should use two separate model. You can use the same high-end model for evaluating ragas as well.
So I had a question. So what is a good raga score? Is it always one?
Okay, yeah. So that is a good question because we talked about the scores and we seen higher score would be good and lower is not good. But what is the good score then? So while one is the goal, so in real world data is too messy. So generally the score which is above 0.8 or 0.8 is considered a very strong score. So the most important thing is to use this score as a baseline so that you can uh, evaluate your system or improve your system based on this score. So of course higher is better, but it is also like you have to somewhere baseline it. Let's say zero point 0.8 is the good score for my application. This would be the baseline, and then you try to improve this score and reach to the level which is you decided. For example, zero point 0.8 is a good score.
I had one more question. So what should I do if my context recall score is high, but my faithfulness score is low?
If we uh, think our analogy, so this means that your librarian is finding the right information, which is the high recall, but your AI is still making things up or giving you incorrect answers, which means low faithfulness. So this usually happens, or this suggests that uh, you need to fix your system prompt rather than your database, or other could be that you can change your model which is generating your response. So LLM model, you can use the different model and then see whether it's improve or it is giving you the factually correct answer.
So, during this explanation about the ragas itself, we also heard something about the ground truth. So, how are these ground truths created for the test purpose?
Mhm. Uh, yeah, so ground truth is the gold standard answer you expect the system to give you. So at the end, what LLM give you the response, that is how you expected, and LLM is also producing that. So you can create this for a small set for important questions. So if you have a huge amount of data to be tested, then just select which is the most important questions and prepare a small data set manually, or you can use LLM to generate the ideal answer based on the source document to use as a reference, and then provide to Ragas framework, and then this will evaluate uh, the matrix is, which is relevant for the ground truth.
So another thing could be uh, historical data could be used. So if we are, solving any particular problem with this RAG, so as a company or as an individual, you may have past data for which you already know the answers or know the correct answer. So that could be used to measure the performance, and that based on like that RAG could be now used further.
So I had one more question. Can Ragas help me decide which database can be used or which database to use?
Yeah. So to answer your question, basically the database is storing elements. So it is storing all the information what uh, user wants. So in RAG case, it is storing all the vector into the database, right? But what plays roles, what is important here is the algorithm, what is used for the retrieval. Like maybe we are using which kind of semantic similarity search algorithm or other kind of search algorithm and so on, which is used to retrieve the relevant data. And if that algorithm is not performing efficiently, then your retrieved context will not be good enough. Or if we like, if the Ragas application itself is using uh, by default some of the algorithm provided by the database itself, then of course, then maybe we need to switch to the database or like that. But the main role here, I think, is the algorithm which is used for the retrieval.
So that wraps up our session today for the ragas and in the retrieval augmented generation. We hope this session is informational to you, and please follow and subscribe to our YouTube channel and Instagram and Facebook pages so that you will be able to get through more and more videos about artificial intelligence and automotive related content.